So, hello guys. Good day. So, to officially start the semester is we are going now to start the discussion with our module 1. So, module 1 is a very siguro ma-amaze mo for this module since from the title itself that is stress. So, before if stress is inyo ra na gina-experience, so karon is inyo pa gina siya ginastudihan. Anyway, that would be a different matter na. Alright, so without further ado, let's just start the discussion. Okay, so in this module, we are going to discuss again all about stress. Alright, kung unsa mo ka stress, how are you going to define stress in this course? Alright, so in this video or in this module, we are going to discuss all about these topics. We're going to discuss the review of the concept of in statics because again sa ako pag-ingon before that whatever that you have learned in statics, it would be very essential in this strength of materials or your mechanics of deformable bodies. So we are going to review that. Siguro na-review na po siguro mo if you have just watched the final exam solutions, so sort of review na po to siya, but anyway I will just have to discuss short review and then I will introduce to you, I will just give you the link on the video discussions in statics just for you to review. Alright? And then we are going now to start the introduction on stresses in members of a structure. What is stress? The introduction to stress. Alright? Kung ano sa stress, that is very different, almost same lang gud gihapon with your what we know about stress. So medyo stress, kung stress mo ron, mas stress ba yun mo because you are going to study stress. So stress tatang tanan. Okay? So after that is we are going to start the analysis of normal stress in axially loaded bar. When we say axial, that would just be the same with normal. Diba? We have your internal forces, we have your normal, we have your shear. Diba? We have your normal and we have your shear. But then again, in this type of member, kaning axially loaded member is ang iyahang if you are going to cut, right, in the member, so sa mga method of sections ta, ang mogawas ra nga internal load would be a normal force. So muna gitawag siya og axially loaded bar. So we are going to discuss that what is the normal stress. And then the average shear stress, so mo gihapon the same gihapon if you are going to cut through that section, ang iharang ma-experience is shear. Alright, shear ang iyang internal force. So we are going to solve what is the normal shear stress or average shear stress, sorry. And then bearing stress. So bearing meaning if ever got touch something, alright, so you will be undergoing bearing stress. Alright, and then allowable stress, and then the last topic would be design of simple connections. So medyo madugo na ning labanan. Alright, pero kaya na. Alright, so let's start with okay, though these are the objectives of these modules is we are going to first again to review some of the important principles of statics and show how they are used to determine the internal resultant loadings in a body, which is again very essential na tong topic is the internal forces nga module in statics because again we are going to analyze internal forces for stress, alright, for stress. And then second is we are going to understand the concept of normal and shear stress. So normal and shear stress pa lang ta for this module until module 4. Yeah, until module 4. So normal and shear stress lang nakasagaran. And then analyze and design. So we are going to now start analysis and design of members that is subjected to both axial load or direct shear. So depende. Okay, so mga members, so we are going to start with our knowledge in statics, then additional trabahoon, that would be your stress and, stress lang. Okay, so are you ready to start with stress? Alright, so first is we are going to review the concept in statics. So first is we are going to start with external loads. Kabalo naman kita that we have external loads nga mahitabo on a member. So we have a surface force. When we say surface force, that is a distributed force, meaning Kailan ba distributed force, di ba? Okay, distributed force. And also, we can have a concentrated force. So, depende. We have distributed force and we have concentrated force. And again, as of this point, since na naman ta sa mechanics of rigid or undeformable bodies, is you are assumed to gain the knowledge or the skill in solving the resultant forces of a distributed loading. So, kaya nimo i-simplify ang distributed loading into a concentrated force. So, muna importante. The second is, of course, the support reactions. Because before, di ba, as what you have experienced, most of you, because some of you are from last year nga statics. So, moto ko ingon lagi nga if ever nga wala ta maka-discuss og support reactions last year, right? Last year is you're going to review that because support reactions is a very important nga process because that would be every problem that would be the first step, di ba? Because dili ka makasolve og internal force if you don't have a reaction. So, start ka sa support reactions. So, general rule, if ang support nimo is ga-prevent og translation, so, dapat na kay force diha nga reaction. For example, if you have a pin support, I mean roller, right? So, wait sa. So, if you have a roller support, for example, okay. So, nag-install pa ko sa pen. Nag-loading. Okay, so for example, we have a roller support. So, mintag roller support, diba? If this is our beam, natay roller dire nga support. Now, this roller, alright, it prevents this beam, alright, isa po natay beam dire, beam na siya, tabutangan dire pin support. Alright? This is a simply supported beam. Now, in this roller support, this support prevents the beam in moving upward or downward. Pwede man siya mo-move dire kilid, di ba? Pwede siya mo-move dire kilid. So, pwede siya mo-translate. Kay roller man siya. So, therefore, wala siya force since wala man siya nag-prevent og translation about X, wala siya force nga ma-develop. So, wala tay reaction diha nga horizontal for pin. I mean, for roller. But, it prevents translation about the vertical axis. Meaning, dili siya pwede mo dito, di po siya pwede mo abot dire. So, therefore, since nag-prevent mo siya translation about the vertical axis, natay reaction diha nga force. Alright? Mao na at if natay roller support, obviously, natay vertical reaction diha. Di ba? Same with the pin. Si pin is, since nakapin man na siya, di ba? Nakapin man gina siya. So, therefore, dili siya move pa doon dito, dili siya move pa doon dito, di po siya move pa doon dito, di siya move pa doon dito. So, therefore, it prevents translation about X and Y-axis or vertical and horizontal axis. Now, if they prevent translation in both axes, that is why we have two reactions if the support is pin. Diba? Muna siya, translation. Now, if the rotation though is prevented, for example, if we have a fixed support, diba? Diba kung fixed support kay, dire, sa pin, sa pin. Diba kung pin kay pwede na siya mutuyok si beam dito? Diba? Pwede na siya makatuyok diha. Kay pin good siya. So, therefore, wala siya ga-prevent og moment. So, therefore, wala kay rotation diha. Wala siya ga-prevent og rotation. So, therefore, wala kay moment nga reaction diha. But if we are going to talk about fixed support, if we are going to talk about fixed support, if we are going to talk about this point, dili ma-move si beam pa doon dito, dili pa doon ma-move si beam, dili ma-move si beam pa dolong dito. So, therefore, it prevents horizontal translation. So, therefore, naatay Rx or reaction about X. Diba? Diri po, dili ta maka-move dito, di po ta maka-move diri. So, therefore, it prevents translation about Y. So, therefore, naatay resultant Y. Kaning fix good na siya. So, therefore, dili na nimo siya malubag pa doon dito, di nimo siya malubag pa dolong diri. So, therefore, it prevents rotation. That is why we have MR or your moment reaction. So that is why if we have a fixed support na atay tulo ka reaction nga mahitabo. Alright, so I hope that's clear. So just to review everyone sa mga wala nakasugat or ang nakalimot na, this would be our reaction. So we have a cable, alright? Cable again that is always pointing away from the member. Okay, tension man na siya, tension. Ruler, we have a one unknown F, di ba? Kung smooth support, that is always perpendicular to the surface. Right? Perpendicular. For external pin, we have two unknowns sa kapag yung ganina. If pin support, we have your vertical reaction, that is your Fy, and we have your horizontal reaction, that is your Fx. The same hapon with internal pin, basta pin gani, two unknowns yun na siya because it will not move or it will not translate about the x and the y axis. And for the fixed support is of course, muna to siya ang three unknowns. That is your Fx, your Fy, and your M. So I hope that's clear again. Sa mga wala pa nakaabot ani, you have to review the concept of reaction. So I'll just share the link on the Facebook group. Alright? So after that is, of course, that is your equations of equilibrium. So mao gina ato pinaka second step. So na natay reaction. Sunod na is here in mechanics, the first step should be the second step would be you are going to use the equations of equilibrium because we are always in equilibrium, right? Equilibrium ko dapat unless sakto good, equilibrium because we are going to talk about stability. Dapat stable good ang imong structure. So therefore, if your structure is stable, dapat all your summation of forces should be equal to 0. So F of y, f of x, so kung 3D, f of z, ila summation should be equal to 0. Remember that. The same also with moments. So kung equilibrium gani ka, dapat the summation of your moments should also be 0. Alright? So please remember that. Again, ako na siya discuss sa statics, so you just have to review or re-remember. Alright? Re-remember. Alright, then we are going to have the internal resultant loading. So, module na ang atong pinaka-highlights. Alright, pinaka-highlight during course. Because again, we are going to analyze member internally. Ang ila deformation, ang ilahang mga internal forces, because it will determine if our material will fail or not. Okay, hinumdumi na siya. Si internal resultant loading, sila ang mag-determine if our member will fail or not. If kaya ba sa ato ang material i-resist ang applied load. Okay, so as what I have discussed in last semester or sa last na to nga sa statics of rigid bodies, we have 4 jud nga internal loading. 2 forces and 2 moments. So we have normal force that is acting perpendicular to the area. We have shear force that acts parallel to the area. Then, for the moment, we have bending moment or gitawag natin siyang flexure that is caused by the external loads that tend to bend the body about an axis. Alright? So, that is your bending moment. And then, last would be your torsional moment or gitawag po natin siya as torque. Alright? So, we have another module which generally talk about torsion in detail. Alright, in detail ng discussion about torque. So this effect is developed when the internal load tends to twist. Right? Twist yun na siya. For example, if this is your beam, for example, alright, ang imuhang normal force is iya ni siya birahon or iya po ni siya itud. Right? Iya ni birahon or iya ni itud. Si shear force is iya ni somewhat makat. Alright? Iya na like kani iya birahon, kani iya pababaw, kani iya birahon pa ubo. So therefore, murag mas-slice ni siya diri sa tunga. I hope na nakagets mo. Alright? Mas-slice siya sa tunga. So, Sprite, back in the man. Okay? So, for bending moment is somewhat, iya na siya, like, i-bend. Alright? Mahimo siyang smile or mahimo siyang sad. Alright? Smile or sad. Si torsional moment that is a twisting moment. So, meaning, kung si bending is pa-smile or pa-sad, si torsional moment is twisting, meaning mahimo ni siya, I don't know if kailan mo shakoy, alright, shakoy, basta shakoy, may inana siya, ma-twist siya something, so that is because of torque or torsional moment. Alright, So that is, those are the internal loadings that may arise if you are going to cut a section along a member. So, muna siya. And then, okay, other important points. So, the mechanics of material is a study of the relationship between the external loads applied to the body and the stress and strain caused by the internal loads within the body. So, in simpler terms, kung asa ko pag-ingon last time, kung si statics is you are going to determine the force, right? You are going to determine the force acting on that member or on that structure. Si mechanics of material is siya ang mo determine if kaya i-support sa load. I mean, if kaya i-support sa structure ang load. Alright? I hope mo nakagets. That's clear. So, that is external forces can be applied to a body as mantaking ganina, as distributed, or it can be concentrated. So, depende rin na ninyo. So, linear distributed loadings is kabalo na ta nga if you have a distributed loading, we are going to express that as a resultant force. So, unsa man ang resultant force distributed loading, that would just be area under the load diagram. So, therefore, we are going to have the area para makuha na to ang resultant force. Now, for the location of the resultant force, kabalo na mo, that is just the centroid of the area. Okay? Then, a support produces a force. So, force lagi, if that it prevents translation, force na siya. Now, if it prevents rotation, we will be having a moment reaction on that point or on that support. Then, for coplanar loadings, only normal. So, coplanar meaning that's two-dimensional. Right? So, here in our strength of materials, wrong spelling dahil siya. So here the strength of materials is what? We are going to have two force only and one moment. So that is your normal force, your shear force, and your bending moment. Now let's review again. Since review man siya, the review for sign convention is for normal force, the positive normal force creates tension. So always yun na, tension kabalo na mo ana. Tension. Now, for the positive shear, it will cause the segment to rotate clockwise. So, dapat clockwise ang movement sa ato ang shear. Then, for positive moment, it will tend to bend the segment concave upward or smile. So, if natay beam dire, if we have a beam here, if this would be a natay moment dire, so kani nga mga moment are positive moment. Nga naman, it will make the beam smile. Alright? Mabend man siya inana. Alright? So, smile siya. Okay. So, I will not discuss this anymore. Alright? This example 1. So, this will make, this would serve as your practice problem. So, I have here the answer. So, you arrive or you review your learnings in internal forces or internal loadings, resultant internal loading to arrive with this answer. Okay, so this would just be a review man gud siya, so I don't have to discuss this anymore. So please do review the concept of this internal loading. So determine the resultant internal loading at C, and this would be the answer. Same here, right? Determine the resultant internal loadings acting on the cross section at C. Okay, murag medyo naguba ang PowerPoint. Let me just edit this for a little while. Okay, so that is our example number 2. So again, I don't have to discuss this anymore since this would be a review. So no need to discuss. But anyway, I'll be muna answer na to for this problem. So again, example 1 and 2 would serve as your practice problem. So sir, unsa man na mo? So I will just be Okay, so prepare for your coursework number 1 on Monday, right? That will be open from Monday 12 noon, and it will be until Tuesday 6 a.m. So that would be 18 hours. So this would just be a wait. Alright? So that would be on Monday, 12 noon until Tuesday, 6 a.m. So that would be 18 hours. Then the coverage would be internal loading and forces on coplanar system. So again, appeal ni siya sa quiz pero di ni siya quiz, alright? Lahi na sa quiz pero it will be recorded under the quizzes, right? Under the quizzes. So we have for your coursework 1, it will be about internal loading and forces on coplanar systems. So two-dimensional lang. Now for the discussion, if ever nga gusto mo mag-review, muna ang ato ang mga videos na sa ubos. Alright, muna ang mga importante nga mga videos that we are going to apply for this coursework. Alright, will be talking, you are going to review free body diagrams, tapos how to solve reactions at supports, alright, and then how to solve internal loadings, preparation for ESci 132 course. Diba? Okay, so I hope that's clear, and see you on our next video.